Welcome to the third video reviewing our stoichiometry problems. We are going to work question 97 on page 395, so you can turn in your textbook to that question. Before I start that question, I do want to draw your attention to the fact that this is in section 4. And you might be saying, hold up, Ms. Frazier, we haven't talked about section 4 yet. Well, what I want to tell you about section 4 is that the one new term that we have in this section is theoretical yield. Theoretical yield simply means the amount that the stoichiometry answer provides. Theoretical yield. This means if I'm told I have 25 grams of a reactant, of one reactant, and 25 grams of another reactant, and I determine the limiting reactant, and then I run the stoichiometry, I do the stoichiometry path, right, from that limiting reactant, then what I get over here, just doing the stoichiometry, what I get up here, that is the theoretical yield. That is, in a perfect world, every bit of that limiting reactant was used, there was excess left over, and I got a certain amount or can get a certain amount. And then we have in this section the term actual yield. Actual yield means hold up, something went wrong. So maybe the stoichiometry tells me that I should be able to produce, let's say, 1.8 grams. And this is a made-up reaction, I should have 1.8 grams produced. But the actual yield, when I run the reaction, maybe something went wrong, or the conditions weren't perfect for this to go forward. So in the actual yield, when I measured it, I only got 1.0 grams of the product. And then this is where we get percent yield. Percent yield means take the actual, divide it by the theoretical, multiply by 100, and that gets us percent yield. So in this case, we would have the actual yield was 1 gram. Stoichiometry told us that the theoretical yield should be 1.8, but something went wrong. And then we multiply that by 100 to get our percent, add the percent sign. So 1 divided by 1.8 times 100. This means that I have a 55.6% yield. That's crappy. That's not good. That means that this reaction is not very efficient. I'm only getting 55% of the product that I should be getting. So in this case, if this was in industry, that manufacturer would want to go back and look at what's happening. Is the equipment dirty? Is the balancing equipment, is the measuring equipment, is it malfunctioning in some way? So, because this is not a good result. So guys, this is the only thing that's different about this section. So you probably want to put in your own words, what is the definition of theoretical yield? Remember, when we do a stoichiometry problem, that's the theoretical yield. That's what should happen in a perfect world, perfect scenario. The actual yield, we will always have to be told that because we aren't running these experiments. So a question would always have to tell us what the actual yield is. Then percent yield is actual yield divided by theoretical yield. So what the problem told me, what my stoichiometry answer was, times 100. And so then again, here is an example of this. So I'm going to work this through for you. One, we're doing question 97 because in question number 97, we have to determine a limiting reactant. And we have actually worked all of the questions already in section 3. So I wanted to find one in your textbook that asked us to work with limiting. So you can see here now a couple things are combined. In this question, we will have to discover the limiting reactant. Then we will have to answer the stoichiometry problem to get theoretical yield. And then we can use actual yield and theoretical yield to discover the percent yield. So let's look at number 97. This says that chlorine forms from the reaction of hydrochloric acid with manganese 4 oxide, and we have a balanced equation. Calculate the theoretical yield and the percent yield if, and here's where I'm going to put my data in. So this is, my information is, I have 86 grams of manganese 4 oxide, and I have 50 grams of hydrochloric acid available. And the question is theoretical yield of chlorine. So how much chlorine? So guys, theoretical yield is the stoichiopath, right? So the first thing we're going to do is that, but, okay, before we do that, we have to find the limiting reactant because we've been given two masses here. So we have to solve the limiting reactant section of this. So this is the review for limiting reactant. So first we have to find the limiting reactant. That's our LR, for those of you who hate that I abbreviate things. Sorry. So how do we do that? We find the limiting reactant by doing the first part of the stoichiometry path, grams to moles. So 86.0 grams of MnO2, and we're going to convert that to moles. So 1 mole has a mass of, and I calculated this, so it's manganese plus 2 oxygens. And let me double check and see that I did that correctly. Manganese is 54.938 plus 32, so 86.94. Remember, this information comes from the periodic table, 1 manganese and 2 oxygens. So we see here I almost have a mole, right? 86 divided by this. So 86 divided by 86.94 is 0.989 moles of MnO2, manganese 4 oxide. All right, so that's part 1 of part 1. Now, you got to find the moles of hydrochloric acid so we can compare. So now we have 50 grams of hydrochloric acid. We're going to convert that to moles. So 1 mole of hydrochloric acid has a mass of, chlorine is 35.453 plus 1.01. So this gets us to 36.46 grams. So 50 divided by this. So I have more than 1 mole. I can see that from my math. 50 divided by 36.46 equals, I can only have 3 sig figs, so I'm going to leave that 1.37 moles of HCl. So now I have done all the work, all the math work that I have to do in order to find the limiting reactant. So now here's what I do. The balanced equation ratio, also stop and try this on your own if you're trying to work along and practice this. The balanced equation ratio is 1 to 4. 1 to 4. And the available ratio is what I just calculated here. 0.989 to 1.37, right? Now, here is where we sometimes say, oh, well, I would like for this to be 1, so I'm going to divide both of these by 1, but isn't this almost 1? So I'm going to logically think I might not even have to do that step here. This is so close to 1 that I can kind of round it and go, okay, rounding, this is 1 and this would be 1.4, you know, just do that. So as we think about that, if this is 1, then this means I only have 1.4, if I'm rounding, 1.4 moles of this available. But the balanced equation says that if I use 1 mole of manganese 4 oxide, I have to have 4 moles of hydrochloric acid. So the ratio, there's not enough of the hydrochloric acid. So hydrochloric acid is the limiting reactant. Hydrochloric acid is the limiting reactant. All right, so then that means that manganese oxide is in excess. So excess is the manganese 4 oxide. Sometimes I'm leaving that 4 out when I say that name. I apologize. So limiting reactant is hydrochloric acid. Manganese 4 oxide is the excess reactant. There will be some of it left over. Now I have to answer the next question, which is it says calculate the theoretical yield. So now to calculate the theoretical yield, I have to do stoichiometry with the limiting reactant. So I'm going to turn the page here. So we're going to do the stoichiometry now with the limiting reactant. The limiting reactant is hydrochloric acid. Now, we already converted hydrochloric acid to moles. So let's just pick up right there with 1.37 moles of HCl. There is no need to go all the way back here to 50 grams because we've already done this section. So now we're just going to do our 2 steps. We're going to use the balanced equation ratio. The balanced equation ratio says that we have 1 mole of chlorine produced for every 4 moles of hydrochloric acid that is available. See? 1 to 4. Those numbers came from the balanced equation. That's the balanced equation ratio. So, and if you want to hit equal and find this number here, that's perfectly acceptable. I'm just going to keep chugging along because I'm not to my answer yet. So now I'm going to say 1 mole of Cl2 has what mass? So this is the molar mass now of chlorine. So chlorine is 35.453 times 2. So that's going to give us a molar mass of 70.906 grams. So now let's pick up our calculator. Let's move that so we can see what we're doing. Let's pick up our calculator. So 1.37 divided by, so times 1 divided by 4 times 70.906 equals, I would probably run that twice to make sure I got the same numbers. I can only have 3 sig figs, so you can see in my calculator I've got more numbers than that. That 8 makes that round. So 24.3 grams of Cl2 has been produced. Guys, when we get that answer, that is the theoretical yield. When we do the stoichiometry path, we have calculated the theoretical yield. Now the question asks us, what is the percent yield? The percent yield. So we have to look back and read the question. It says that the actual yield is 20 grams. So now, based on what I showed you earlier, I'm just going to put this back up here. The actual yield goes over the theoretical yield. This was given to us in our problem. It has to be given. The theoretical yield is 24.3 grams times 100. So 20 divided by 24.3 equals times 100 is 82.3%. That is excellent. The question you have to solve now is question number 93.